Good afternoon once again. So we have already discussed the strategy of divide and conquer in some details in the two earlier videos, and I've also explained to you the various problem solving strategies that are employed while writing algorithms. So they are brute force, greedy, dynamic programming and divide and conquer. If you wish to understand these strategies in more details, I'd suggest checking out my previous video where I've covered each of those topics in details along with an example of each type. So now in this video we'll be concluding this discussion with a brief recapitulation of what divide and conquer actually is and how it differs from the conventional linear problem solving approach. So let us recall what we discussed earlier. What is divide and conquer basically? It is a recursive problem solving technique. So I hope you understand what is recursion. Recursion means doing something again and again until a criteria, that is a base condition or a base case, is satisfied. So it involves three steps. Divide the problem into smaller sub-problems. Okay, so you are just dividing a large problem into smaller chunks, then conquering each sub-problem recursively. So once you have reached the stage where the problem cannot be divided any further, what you are doing is you are beginning the conquer phase, which is the next phase in the divide and conquer approach, where you combine the solutions of the smaller parts progressively into a single larger part, and you do that in a recursive fashion. After conquer, you combine all the solutions and you arrive at the final solution. Some examples of divide and conquer are merge sort, quick sort and binary search. And a real world analogy of this situation is, all of you in your high school history classes, you knew how the British exploited India and the Indians. So as I was saying, you all know how the British exploited our India, our country, and how they did that was they created a division among the Hindus and the Muslims. Before the arrival of the British, all Indian citizens were united. They did not have any kind of divisive sentiments among themselves. So the British felt that they were difficult to conquer. So what they did was they created a rift or a division between the two sects, and when both of these sects started fighting among themselves, the British conquered our country. That is, they established their foothold in our country, which lasted a very long time, and it also damaged the country in many ways permanently. So this is an example from the real world. Okay, so now let us compare the divide and conquer strategy with linear algorithm. So linear algorithm means the most basic type of algorithm in which you solve a problem in a single pass without actually dividing it into smaller sub-problems. So let us say you are searching an array, searching a number in an array containing 10 elements. So if the number lies at the end of the array, you will have to compare the number that you are searching to each and every number of the array. So you will have to go through the array n times from 0 to n, from 1 to n. So that means the complexity will be on. Okay, so it is the worst case complexity, where if the number is situated at the end of the array, you will have to compare you will have to compare the number that you are searching with the rest of the numbers in the array, in which a lot of time will be consumed. So this approach is not ideal while solving the larger problems. So it may be simple, as it says in the next statement, it is a simpler and faster approach for small and straightforward tasks, but it will not be suitable when it comes to larger tasks and more complicated tasks. Examples are linear search and iterative summation. Okay, now let us see some differences between divide and conquer and linear approach. So divide and conquer, the basic approach involves dividing a problem into smaller sub-problems and then solving them and then conquering them, that is combining the results of these problems. So what we do here is we divide it into smaller sub-problems, that is, and solve them. That means we employ recursion over here, and it follows a tree-like approach where from the parent problem you are creating a child problem, and then you are subdividing the child problem into even smaller two smaller children. That is, you are going on dividing until further division is no longer possible. So from the parent you are creating a child, so from that child maybe you are creating some more offsprings, and you are going on and on. So it creates a sort of hierarchy. That means it creates a branch. So you will have to solve the problems in a bottom up approach. So you will have to solve the bottom problem, the problem at last, at the beginning, then the very next problem, then the problem after that, right after that, until and unless you arrive at the parent node. Okay, so because of this it can be termed as a hierarchical problem. So it follows a tree-like approach. So it will become more clear. This approach will be, you can understand it better when we will be discussing some examples of divide and conquer later in the later videos. So linear algorithm is sequential. That means it involves no division and it can be solved in a linear way. Okay, it is a simpler approach, so no division is required. Time complexity is O log n. That means as you are dividing the problem into smaller fractions or smaller chunks, log n tells us how many times you can divide the problem until you are coming to a state where further divisions are not possible. Okay, so it is O n log n. That means you are dividing the problem into sub problems which takes up log n time, and after dividing, when the conquer phase begins, you are combining the results of each of these sub problems into a larger problem. So it will be n into O log n, because when you are combining it you are getting a set of n numbers. So n into O log n, that is the complexity. And the linear approach, as I have discussed earlier, it takes O n time, because here we are going through each of the possible solutions one by one until and unless we get the desired result. So in the worst case it usually takes O n time, and in the divide and conquer recursion is used. In linear approach it is not used. Ideal use case is large complex data sets for divide and conquer, and for linear algorithm it is usually simpler, smaller problems, because if you are solving a large problem, only then it makes sense to divide it into smaller halves. But if you are having, say, if you are asked to sort a list of 5 or 6 numbers, it makes no sense at all to divide it into smaller problems. Now some examples: merge sort, where it is recursively splitting the arrays. We will be discussing merge sort in details later on. It is just an overview. After splitting the arrays, it merges the sorted sub arrays, and its complexity is n log n. So a linear sorting approach is bubble sort. So it is comparing two adjacent numbers in a loop. So there are two loops where you are comparing a number and the number immediately adjacent to that number, Okay, and so as you are going through the comparison twice, there are two loops. Because of that, the complexity is O(n) square. Next, the benefits of divide and conquer. It is a faster performance. It gives faster performance on large data sets. Obviously, if you are solving a larger problem, it makes sense to divide it into smaller fractions so that you can solve them in a more efficient manner. It gives better scalability for complex problems. So if you are dividing it into smaller fractions, you can solve it easily, and you can apply this approach to a wide range of problems, okay, of varying sizes. So it scales well with the size of problems. Optimized recursion leverages system stack. So while you are solving it in a recursive approach, you are storing the results on the system stack, so the memory of the system is also utilized in a optimized fashion, and it solves problems that can be efficiently tackled linearly, suppose binary search. Okay, now some real world applications: merge sort, quick sort in libraries, FFT Fourier transform in signal processing, binary search in databases and software tools, matrix multiplication in scientific computing. So I am not discussing these applications in details because it is, to be honest, out of the scope of our current session. So if you want to learn about each of these approaches, merge sort and quick sort, I will be demonstrating later on, but the other topics you can look it up on various websites like Wikipedia. Now, when not to use divide and conquer for smaller data sets. If you are having a smaller data set, dividing and then combining will not be worthwhile. It will take up a lot of time, and it will lead to a wastage. Okay, so this is not recommended for smaller problems. When the problem is simple and doesn't benefit from splitting. Okay, so if you are asked to find the largest and smallest values from a list of say 6 numbers, is it really necessary to split the set of numbers into smaller subarrays or smaller sublists? No, it is far easier and far more straightforward if you directly follow a linear approach and try to solve the problem and identify the maximum and minimum values from the list by comparing each of those numbers one by one. So even though the complexity will be O(n), it will still be much more efficient, and you will not have to face unnecessary overheads of dividing and then conquering. And what is the conclusion? Conclusion is, it is a powerful strategy for complex problems. It outperforms linear algorithms in large scale or recursive friendly tasks. So for problems such as merge sort, quick sort, which are optimized for recursive approach, divide and conquer will be very useful. And whether to apply divide and conquer to a particular problem depends on its size and complexity. Okay, so you will have to keep that in mind before you are applying divide and conquer to any particular problem. So this is the conclusion of this video. So in the next few videos we will be exploring some problems that can be solved using divide and conquer, like merge sort, quick sort, etc. Thank you all.